Hello students, welcome to the next lecture on the CSR Net examination solution. Today we will discuss about all those questions related to the linear algebra from the paper December 2017. We will see all those questions with the help of the shortcut trick. Myself Dr. Garg. You can simply follow my YouTube channel or else you can join my WhatsApp group by using this scan and join them where you can see the various discussion part. What you will be found on my YouTube channel, you can see the playlist CSIR UGC Net where you can find the PY questions on the partial differential equations from the year 11 to 2023, PY question on the differential equations, calculus of variation, integral equations, as well as the eigenvalue. These are most important topics for you related to the linear algebra. And then we will see the LPP solutions, differential equations, statistic solutions, and many more. All are available in this CSIR UGC Net playlist. Now we will see how you can solve this December 2017 questions. Remember that whenever there is a question related to the linear algebra and it come discuss about some matrix, then always think about the eigenvalue. You can try to solve each problem with the help of the eigenvalue. That is a simple tips for you. We will see in this video we can try to solve each question with the help of the eigenvalue. Now let's start with this one. What is given to you? This is a part B question, so it is only one correct option is there. A is the real symmetric matrix. So let's assume that lambda is the eigenvalue. What is the meaning of that? The eigenvalues are my real. And what is the eigenvalue of the B? Can you find the eigenvalue of the B from here? It will be 1 plus iota of this. Then you can think about their option. B is invertible. What is the meaning of that? Determinant of B is non-zero. What is the meaning of that? If 1 plus iota here, 1 minus iota is also the eigenvalue of this. It means this will be non-zero. Can you say it implies A is invertible? That means none of the eigenvalues is 0. But that is not true. Why? Because A is my real symmetric value. So A can be a 0. So if lambda is 0, then the eigenvalue of B is my 1, which is non-zero. So it means if and only if condition is not true. So that is this here. All the eigenvalues are necessarily real. That's fourth statement, because the eigenvalue of the B are my 1 plus iota lambda. So since lambda is my real, so 1 plus iota is always be the imaginary part. So this option is also cancelled out. B minus I. What is the eigenvalue of the B minus I? Eigenvalue of the B is 1 plus of this. Eigenvalue of the I is my 1. So eigenvalue of this is iota of here. So it is necessarily invertible. That's again not true. Why? Because whenever lambda is 0, lambda is the eigenvalue of the A. When lambda is 0, then this is also be a 0. So which is not invertible. So this option cancel. B is necessary invertible is the right answer, because it is word of the necessary. That is not true. And B, what is the eigenvalue of the B is 1 plus iota here. So whenever lambda is 0, for example, then still it is a 1. So it means the right answer is only fourth is the right answer. Okay, now again this is related to the matrix. So we will try to think about the eigenvalue. How you can find the eigenvalue? We can write the characteristics equation. What is the trace? Trace is my 1. What is the determinant? Is my plus 1. Now your target is to find A1 is 1, A of 2 is I, A of 4 is I, A of 6 is equal to I. The first method is you can find the A square by the matrix multiply. Then you can find the A4 and then check which one is the correct. But what is the shortcut tricks for you? Have you think about any of the formula? That is any of the identity which relates to this? If I multiply this by lambda plus 1 on the both side, what is that? This is nothing but of this. So what is the meaning of that? Lambda cube is minus 1, but we need a plus 1. We need a plus 1 on each side. So lambda of 6 is my plus 1. What is the meaning of that? A6 is my I. So what is the meaning of that? The right answer is again fourth option is the correct one. So you can always think about the eigenvalue and then you can trace back on that. Okay, now look at this one. So a matrix is given to you and system AX has a solution or no solution. So look at that. Whenever the rank of A argumentic B are same, then you can say it has a solution. Fine. And we all know if it is equal to the number of the column vectors, then we can say it's a unique solution. If they are not equal to this, then we call as the infinite many solutions, and if they are not equal, then we call as the no solution. They're very simple task, but there is no need to reduce them. I will tell you the shortcut tips for you. This is my A, this is my B. Fine. So whenever this is depending upon the alpha and beta, so whatever is here, alpha minus something, here is beta minus something. That is the only condition will be happen, whatever the results are there. Now look at that. What is the meaning of the no solution? It means rank of A is not equal to the rank of A condition B. Fine. So now it means this value must be the 0. So it means its value must be dependent on the alpha. It will be 0 when only alpha will be there. But here there is no alpha. So it means this condition is cancelled out. Again look at that infinite number of the solution. When it will be the infinite number of solution? When determinant of A both are same but not equal to 3, because there are the 3 columns are there. So when it will be there? When this will be 0. So when alpha minus something will be 0, it means alpha is that something, and similarly beta is that something. That means equality will be there, but here is not equal to, so that is also cancelled out. Infinite number of the solution, again when this will be 0 and this also will be a 0, otherwise this is a no solution. So this option is also cancelled. Right answer is only A. How you can check that? What is the unique solution is? It means both are equal and must be equal to 3. So if when it will be the 3, when this component is non-zero, it means that component must not be equal to something. That something is given to be 2. Whatever the value of the beta, because once it has the rank 3, the argumentative matrix always has the rank 3. This is the first method. You can simply solve with the help of the options. Other way, how you can check the unique solution? You can see that determinant should be the non-zero. You can find the determinant of this. So that is alpha minus 3 plus 1. That is my alpha minus of 2 plus 1. 3 minus of 2 is a non-zero. So you can see alpha minus 3, alpha minus 2 plus 1 is non-zero. So what is that? 2 alpha minus 4 is non-zero. So alpha is my non-2. That is my right answer is B. But you can just think about this option. You can get the answer without solving the problem. Okay, now again the matrix is given to you. You have to solve this value with the help of the eigens value. Okay, so there is a bilinear map is given to you. Phi of this is of here. Now think about that. Do you think any of the term, any of the concept which is related to this? Yes, this is related to the quadratic form. We all know this is related to the quadratic form. Then what is the first condition is given to you? Okay, so what is the first condition is? That is symmetric. VW is here. So it means this will be equal. It will be equal only when A is my symmetric. This is only happen when A is my symmetric. So do you think that, what is that? Is it asymmetric? No. A is not symmetric. So it means the first option is cancelled out. Look at the second option. Phi of VW is 0. So when the quadratic form will be 0? Only when A is, or you can say that determinant of A is my 0. Or you can say 0 is the eigenvalue. So can you find that determinant of A? What is the determinant of A? 3 minus 8, which is a non-zero. So it means this condition not satisfied. This option is also cancelled out. How you can find the eigenvalues? You can clearly say what is the eigenvalues of this. So what is that? You can clearly say the sum of the column is my 5. So one of the eigenvalues is my 5. And you know the sum of them eigenvalue will be the trace. So the trace will be 4. So these are my eigenvalues. And again say that the determinant of A is minus 5, non-zero. So second option is cancelled out. Look at the third option. There exists a 2 cross 2 symmetric matrix which is like here. So if you look about there is, can you transform A to the B which is of the symmetric? Yes, you can do. Whenever there is a 2 cross 2, how you can convert them into the symmetric matrix? Preserve the diagonal. You can preserve the diagonal of this, and these are the non-diagonal entries. That's a 4 plus 2. Take the average of this. 4 plus 2, that's my 3 comma 3. So this is my symmetric matrix. And if you multiply this by V, that is say V1 or V2, and this is V, again you will get the same as of the phi VV. So that is the right option, because there is the existence of the matrix here. So since only one correct option is there, so that's the right answer. But how you can discard them? Linear. So what is the property of the linear? That is, when you multiply with alpha of say x, it must be alpha times property of the x. That is the property of the linear. Now if you think about that, if you multiply this by alpha, so this is alpha v, alpha w. So if you think about here, this is alpha transpose v of alpha of, but alpha is my real, so this component and this component, it will be alpha square, which is not equal to alpha. So this option is also cancelled. So the right answer is only C. Now look at the part C. So how you can, it means it has more than one correct options. So again, what is given to you? F of x is my x transpose A x. F is my any mapping from R4 to R. A is my matrix of the real, only real. Then you have to find the gradient of F. What do you think about that? I again said you can solve this within a 15 seconds. How? What is the nature of this? This is my quadratic. So whenever there is a quadratic, what is the gradient of this? It's a linear. When it is a quadratic equation, then gradient will be the linear. So what is the gradient of this? Is always A into A transpose x. So now you have to find the gradient at the x0. What is the answer of this? A plus A transpose of x0. So that is my right answer of this problem. Now what is the tips for you? That's a very simple tips for you. Look at that. This A is any matrix. If my A is symmetric matrix, for example, if A is my symmetric matrix, then we all know A is my A transpose. Then what will be the gradient? Gradient will be 2A x0 or 2A transpose x0 or A plus A transpose x0. Then in that case, if A is my symmetric, then A, B and C, 1, 2 and 3 are my correct option. But here it is not given as a symmetric matrix. So the right answer is only about this concept. That is a B is the right answer. Okay, now look at this again. This is question number 72, which is again part C. So it has more than one correct options. Now how you can solve that? If A is my m cross n, A is my, okay, then the linear system Ax is equal to B has a solution. So it is solution is given to you. What is the meaning of that? Either it has infinite many solution or it has a unique solution. What is the property of the infinite many solution, the unique solution? Rank of A must be the rank of the A condition B. In both the cases, whether it is equal to n or not equal to n, that's depending upon infinite. But the major is both have the same. So what is the meaning of that? Now you can see, if you think about the A condition B, this is my B. What is the size of this? It is from the Rm. So what is the meaning of that? Rank of the A condition B must be of the m vector. But here rank is given to you R. So what is the meaning of that? It means m is equal to R is there. So the first condition is m is equal to R. Fine. Now if also we know that if it is m cross n, the rank will be minimum of the m cross n. So what is the meaning of that? N must be greater than or equal to m. This condition holds. Fine. So whenever this condition hold, and if this condition is given, what is the meaning of that? It implies this also. So this part is also correct option. Fine. Now look at the other two options. Firstly, the null space. What is the meaning of the null space? Is Ax is equal to 0. Fine. Is a non-trivial solution whenever m is equal to n. So whenever m is equal to n, then A is my n cross n matrix having the rank of A is n, because m is equal to n, the rank is my m, that is here. So what is the meaning of that? If the matrix A has the rank n, which is the number of the column, what is the meaning of that? determinant of A is my non-zero. Once the determinant of A is non-zero, it will give always be the, what is that? It's a trivial solution. What is the solution is x is 0, but they are talking about the non-trivial solution. So this option is cancelled. Fine. Now look at the last option. Column space of the A is my proper subspace. Okay. So you have to put one counter example. A is my m cross n. So consider m is equal to n and say this is rank. Rank is say my 3. So it means if I consider any of the 3 cross 3 matrix whose rank is 3, then the columns are my proper subspace. That is again not true. What is the meaning of the rank 3? Rank of A is 3. What is the meaning of that? It has, so matrix A has 3 Li column vector. So what is the meaning of that? But for the proper dimension subspace, what is the dimension of the matrix? It should be less than of this m. That means it must be the less than of the 3. But we see there are the 3 linearly independent vector. So the dimension is my 3, but it is a less than 3. So this option is also cancelled out. So that's our right answers are my A and D are my correct options. Okay, now look at this another question that is related to, again the matrix is given. We will think about the eigenvalue. What is given to you? M is any of the A, B, C, D are my integers. Eigenvalues are in my Q. Then M is my empty. I think that is again the wrong option. If I consider M is I, 1, 1, 0, 0. A, B, C, D are integers. What is eigenvalues? Eigenvalues are my 1, 1, which is also the part of the Q. So M is a non-empty. So I must belongs. That's a cancel out. Second option is M, A, B, C, D, where A, B, C, D are my integers. So what is that? Again, I think how you can discard this option when you will provide the example in which lambda is not belongs to the Q. If I prove that lambda belongs to the complex number, it means it is not in the Q, so that option will cancel out. So what is that? If I just consider this as a 1, 1, 0, 0, 1 minus 1. So what is the characteristics equation? Lambda square plus 1 is 0. So what are the eigenvalue? Iota minus iota, which is not in the Q because this is a part of the complex number. So M, this M does not belong to this. This option is also cancelled out. A, if A belongs to the M, what is the meaning of that? A belongs to the M means whatever the eigenvalues, they are in the form in the Q. Or you can see the characteristics polynomial corresponding to this eigenvalue is reducible in Q. That's the meaning of this, because whatever the characteristics equation you can write, this is sum of the eigenvalue and product of this is the characteristics equation, which, or you can say characteristics polynomial reducible in Q. Whenever any of the matrix or any of the polynomial reducible in Q, what is the meaning of that? That is also reducible in Z. So what is the meaning of that? If any of the polynomial is reducible in the integer, then their roots is in the Z. So the polynomial has the root eigenvalue. So eigenvalue must be of this integers. So that means this option is correct option. Look at the last option. If A and B belongs to the M, what is the meaning of that? A and B belongs to the M. It means their eigenvalues are the part of the Q and it is also the part of the Z. So it is reducible in Z such that AB is equal to I. That's very simple. If you take the determinant, this is my 1. So when it will be possible? It has the eigenvalue say lambda, it has the eigenvalue say mu. So lambda mu is my 1 and we all know these are my integers. So take any two integer number whose product will be 1. This is only possible when lambda and mu are either minus 1 or plus 1. That is, the determinant of A or B is either plus 1 or minus 1. That's a open, that's a set. So the right answer is my C and D are my correct options. Okay, now again look at this part C. Again more than one correct options are there. Again this is the matrix. We can think about the eigenvalues. Okay, it's a diagonalizable. So firstly I will tell you how you can check the matrix is diagonalizable. First one, if the matrix has n distinct eigenvalue, then it is a diagonalizable matrix. Second property is, if algebraic multiplicity and geometric multiplicity of each eigenvalue is same, then it is a diagonal. Fine. So look at that. Second option is correct. If A has the distinct eigenvalue, then it is a diagonal. If A has the distinct eigenvalues, then it is also here. So second and third are correct options. A is necessary diagonal. That's a wrong option. That's a very, in your graduation or in the post graduation you have solved many of the examples which are not because here A is diagonal. So we can consider any of the matrix. Say diagonals are 0, say 0 and say 1, 1 and 0. Clearly say what is the eigenvalues? 0, 0, 0. What is the algebraic multiplicity of the 0 is 3. What is the geometric multiplicity of 0? How you can find? That is the n minus rank of A minus. So lambda, what is the eigenvalue is my 0. So it is n minus rank of A. What is the rank of A? There are the two non-zero elements. So 3 minus 2, which is 1, which is not equal to algebraic multiplicity. So it means this is not here. Or if you think about here, then the rank will be 1. Then again it will not be this one. If all the eigenvalues are the non-zero, then again you can think about again this example. Say 1, 1, 1, 0, 0, 0. Say 1, 0, 0. What are the eigenvalues? 1, 1, 1, which are non-zero. Algebraic multiplicity of the 1 is 3. What is the geometric multiplicity is? Again by using this rule, n is my 3, rank of A minus I. So if you find A minus I, it will be 0, 0, 0. So rank will be 1. So 3 minus 1, 2, which is not equal to 3. So this option is also cancelled out. So the right answers are my B and C are my correct options. Okay, look at the another one. What is given to you? V is a vector space of the polynomial of degree at the most 3. So what are the bases of this? These are my bases. D is a polynomial with respect to the differentiation. So this is my derivative with respect to the x. A is a matrix associated with D. So we can find the matrix easily. So I can take as 1, x, x square, x4. This is a 4 cross 4. Firstly, I can take as a 1. What is the derivative of this is 0. There is no coefficient. So 0 I can written as 0, 0x, 0x square and 0x cube. Second is I can take x. What is the derivative of the x is 1, which is a constant. Other values are my 0. What is the derivative of the 2x? It will be my 2. Sorry, x square. X square is my 2x. So constant is 0. X is my 2. Others are 0. Derivative of the x cube is 3x square. So x square is my 3. Rest are my 0. So what is that? This is my diagonal matrix. So what are the eigenvalues? Here. So it is 4 cross 4. All eigenvalues are my 0. So what is the meaning of that? The matrix A is nilpotent. Fine. Any of the matrix whose all eigenvalues are my 0, remember the word all, then it is always be a nilpotent. So that is fine. First statement is correct. Second tips for you, whenever there is a nilpotent matrix, it can never be a diagonalizable matrix. Fine. So the second option is cancelled out. What is the rank of the A? You can clearly say that what is the rank of the A? Rank of the A is my 3 because 3 non-zero rows. So this option is also cancelled out. How you can find the fourth option? So that is the Jordan block. How you can find the Jordan block? We can find the minimal polynomial. Fine. So the characteristics equation will be here. So we can find the geometric multiplicity corresponding to the 0. So what is that? N minus rank of A minus 0i. That is 4 minus 3. Rank is my 3, 1. So what is the meaning of that? Geometric multiplicity of the 0 is my 1. What is the meaning of that? It means there is only one block of size, same size as of the matrix A, that is a 4 cross 4. So once it is of the same size of the 4 cross 4, diagonal entries are always with eigenvalues, and the upper, that is upper values are my 1, rest all are my 0. So that is the same here. Diagonal values are my 0. Upper diagonals are my 1. Rest all are 0 is also the correct option. So the B, C and D are my correct answers of this problem. Okay, now look at this another one. So again it's a matrix. So we think about the eigenvalue. It is a symmetric. So the eigenvalues are my real. It's a non-singular. So eigenvalues are my non-zero. Then there exists a positive integer. P must be greater than 0. Such that here, fine. If A has the eigenvalue this, what is the eigenvalue of the Pi plus of the A? So that is my P plus of this. What is the meaning of the positive definite? Positive definite means all the eigenvalues are my greater than 0. That's the meaning of this. Now, A is a real symmetric matrix. So lambda can be greater than 0. It can be less than 0. Assume lambda is my minus of 10. Then can you find P which is greater than 0? There exists. Can you find the P such that this value must be greater than 0? Yes, you can take P is my 12. So 12 minus 10 is greater than 10. So it means there exists them. Right answer is here. If A has the eigenvalue this, what is the eigenvalue of the A raised to power P? Lambda raised to power P. So again, if lambda is my positive, P is already positive, so this number is greater than 0. If lambda is my negative, so say minus of 3, can you find the value of the P so that it will be greater than 0? Yes, you can do that. If I take P as my even number which is greater than 0, so again you can find the P because if there is a word of the always, then it will be cancelled out. But here there exists them, so this option is also correct. What are the eigenvalue of the A raised to power minus P? Lambda raised to power minus 1 of P. So since lambda is non-singular, so it means lambda is my non-zero. So it means it is a 1 over this. Again, if lambda is my less than 0, you can find P as my even number. If lambda is my positive, then P can be of the anything. So it has the value positive definite is the right answer. What is the eigenvalue of the E raised to power PA minus 1? A has the eigenvalue lambda, so it has a P of this. When it has the positive, when it will be the greater than 0. What is the meaning of that? P e raised to power P lambda is greater than 1. It means P of lambda must be greater than of the 0. Fine. But I think that is not true, because if you take lambda as a minus of 3, can you find a P which is a positive such that their product will be greater than 0? You can never find that. It means this is not a positive definite. So the right answer is A, B and C. This will be positive only when either both are less than 0 or both are positive, but P can never be less than 0. So the right answer is A, B and C are my correct options. Okay, look at the last example. So A is my M cross N, having the rank of the matrix is my M, and N is my greater than M. Some non-zero alpha is my non-zero, such that of this condition holds. X transpose A transpose is alpha X transpose of X. Then you have to find the values of this. Firstly, I can find the value of the A transpose A. So I can take that transpose on the both side. So what will happen? X transpose of transpose is A. It is A transpose, and X. Alpha is a real number, this is same. So which is the same as that of this. So I can write this number, since alpha is a real number, so I can write this alpha as here. So X transpose I can take common. A transpose minus alpha I of X is 0. Fine. So what is the meaning of that? It means A transpose of this, because in the previous example I already told you this is quadratic when it will be 0, when A is my singular matrix, that is determinant of A is 0, that is here. So what is the meaning of that? A transpose is my alpha. Fine. So if I consider this number as say B, so it means the determinant of B will be my alpha of this. So what are the eigens values of A transpose? Alpha. What is the size of the alpha is? M cross M, because the rank is my M. Now what is the meaning of that? What is the size of the A transpose A? What is the size of the, what is the A's M cross N? transpose is n cross m, so that this value has of n cross n, and n is my greater than m, so it means it has, these are my m values and the remaining values are my 0 0 0, how many times, n minus n times. Fine. Now you can find the eigenvalues. Now you can think about that. Exactly two distinct eigenvalues. That's true because alpha is my non-zero which is given to you, and it is a 0, so it has the two distinct eigenvalues. That's the correct option. 0 is the eigenvalue with multiplicity n minus m. You can see here n minus m is the 0 multiplicity. That's also the correct. Alpha is the non-zero eigenvalue. Alpha is also the non-zero eigenvalues. Exactly two non-zero distinct eigenvalues. That's wrong because it has one zero eigenvalue. So this option is cancel out. So the right answers are my A, B and C are my correct options of this matrix. So that's a very simple target about that. You can simply solve this all question with the help of the eigenvalue in a very simple conceptual method. I hope you can learn the concept. We will see the next lectures on the algebra, linear algebra related to the June and the December of the 18 paper. Till then, you can simply like, share and comment my videos. Best of luck students. Happy learning.